Morning, dear students. Today I am going to discuss about the next chapter, and that chapter is Gauss theorem. But before I start this, I want to tell you why this Gauss theorem comes in existence. So dear student, you know in the previous chapter the electric field due to a point charge, suppose a point charge q, and the electric field due to a point charge at distance r, you can easily calculate E is equal to 1 upon 4 pi epsilon naught q by r square. And here this q is a point charge. Point charge means where the charge is confined at a small place. And this formula is valid, or this formula is applicable for electric field due to a point charge. But if the charge be spread on any surface, suppose if we will take a line or conductor, and suppose the charge is spread over its surface, means this charge is not confined, then how can we find the electric field due to this distribution of charge at distance r from it? So in this case, for finding the electric field due to a distribution of charge, here we will use the Gauss theorem. Similarly, if we will take a sheet of metallic, suppose we will take a metallic sheet, and suppose a charge is spread over it, and our aim is to find the electric field due to this sheet of charge at distance r from it, then also we can find the electric field due to the sheet of charge at point P by using the Gauss theorem. So Gauss theorem is used for finding the electric field due to distribution of charge. So first topic in the Gauss theorem, I want to tell you what is a area vector. Area vector. Dear student, you know, I hope maybe this concept or this things will arises in your mind. The area means length into breadth, and when you will take length into breadth, then you will get the magnitude of this area. But actually area is a vector quantity. Always remember this, area is a vector quantity. It means it has both magnitude as well as direction, and the magnitude of that area vector you can find by taking the length into breadth, as you know, or you can find out the magnitude by taking the area of that. And direction, to direction of this area vector be always perpendicular to that surface and directed outward. Like suppose this one is any surface, its magnitude of its area is a, and as you know area is a vector quantity, it means it has also the direction. Direction means this one means here, which is perpendicular to this plane and directed upward. So always you remember this, the direction of this area vector, which is represented by this n unit vector. This n unit vector is giving the direction of this area vector, and this one is also called axis of this area vector. So either you say here direction of area vector or axis of area vector, and this direction is represented what here, vector a. It means the magnitude of this area is a, and direction is always perpendicular to this surface, means this area, and directed outward. Always it will be directed outward. Suppose this whiteboard, we will consider this area, then its magnitude is length into breadth, but the direction of this area vector is what here, perpendicular to this area, and like this one is a perpendicular to this area and directed outward, not inward. So this will be give the direction of the area vector.
Ready.
So dear student, here we consider area is a vector quantity which has both magnitude as well as direction, and I hope it's clear to all of you where you will take the direction of this area vector always perpendicular to that area or normal to that area surface and directed outward. And suppose this perpendicular to this surface and directed outward, this one is the area vector which is given by n cap, and this n cap is given by, means this direction of this area vector is given by, this one is unit vector. It means area vector upon magnitude of its area, or you can say vector A is equal to n cap into A. So simply here I want to tell you only one thing. The area is a vector quantity whose direction is always perpendicular to that surface and directed outward, and this will also called axis of this area, or simply you can say area vector. Next topic is solid angle. Dear student, all of you know very well about the plane angle and also solid angle, and already you have studied in the class 11th solid angle whose unit was steradian. So here I am going to tell you what is a solid angle, but before this one, first solution, what is the plane angle? You know, if we will take a circle and suppose O is the center of circle, and when you will take any segment of this circle, suppose that segment is AB, so the angle subtended by this segment AB at center is suppose theta. So this angle theta is called plane angle. This one is called plane angle. But if you will take a 3D figure, like if you will take a sphere, suppose this one is a sphere, this one is not circle, this one is a sphere, and on this sphere if you will take a small area, suppose this one is a small area you have taken on that sphere, suppose total area of this sphere is A, so a small area on this sphere is denoted by dA. This one is a small area element, and now the angle subtended by this small area at its center, this one is what here? Solid angle, and a small solid, total solid angle is denoted by omega, and solid angle due to a small area is denoted by d omega. So simply the angle subtended by the small area of this sphere at its center is called solid angle, and this solid angle d omega is equal to dA upon r square. Here dA is the small area element of that sphere, r is the radius of the sphere, and d omega is the angle or solid angle subtended by that small area at the center. Then by definition, this small solid angle d omega due to this small area dA is given by d omega is equal to dA upon r square. So dear student, this d omega is the small solid angle due to a small area. Now a question arises here, how can you find the solid angle due to entire sphere or entire surface? So for finding the solid angle due to entire this sphere or for all this sphere, what you will do? You will integrate this one. Integrate means sum up. So for finding the solid angle due to entire sphere at its center, you will integrate it, you will get d omega is equal to dA upon r square. And as you know, integration of dx is equal to x, or integration of dt is equal to t. Similarly, integration of d omega is equal to omega. And here r is the radius of this sphere. This one is a constant for every place. So you will take this r square means 1 upon r square outside, and here you will get dA. It means omega is equal to 1 upon r square, and integration of dA. dA is the small area element of this sphere, and when you will integrate it, then you will get completeness total area of this sphere A. And you know, area of this spherical surface is 4 pi r square. Remember this one is a sphere and its surface area 4 pi r square. Now r square is cancelled by r square, so here omega is equal to 4 pi. It means, dear student, always you remember this, the solid angle subtended by a closed surface, the always 4 pi. And this one I am talking about the solid angle. And all of you know the unit of the solid angle is steradian. So this one is steradian. Here one more thing I want to tell you. If any surface be rotated through an angle theta, then how can we find the solid angle? Suppose this one is any surface this one, and from point O its distance is r. From point O its distance is r, and suppose for this area vector its axis is along this one. Suppose this one is axis of this area vector, this one. Now when it rotates through an angle theta, suppose this angle is theta, this one, then for finding the solid angle subtended by this area element at this plate, suppose d omega, then here you can write d omega is equal to dA, and component of this one along this direction is dA cos theta upon r square. So please you learn this formula, d omega is equal to dA cos theta upon r square, when this area is simply rotated through an angle theta. So simply you can say d omega dA cos theta upon r square. And once again I want to tell you, in area vector always we consider the direction of that area vector be perpendicular to that area and directed outward. Once again I want to tell you, for example this one complete whiteboard, I am taking this one is area length into breadth, and for finding the direction you will take it like this one. And remember this, when you will rotate this or when you will move this one area, it always like this, it will be never change. It means it will always perpendicular to this surface and directed outward. So dear student, today you will go through these 2 points, and again I will give you the next topic, electric flux. But if you have any problem in this one, then please you can ask. Thank you.